Girls, can I go through the solutions for the questions on page 383 in your textbooks? So in the first one, you had to draw and name structures. So I'm just going to go through them very quickly. The first one was 2-methyl-propane. So you draw, propane means 3 carbon chain. You draw 3 carbons, link them together. On carbon number 2, there's a methyl group. Now that was, I didn't say this to you now before you tried this, but if your structure, if you look at that question, there was CH3, CH, then in brackets CH3. So if you see something in brackets beside a carbon, then that means it's a substituent group. And then the next one was the CH3. So drawing that out, you get 2-methyl-propane. In part B, you were given CH3, CH2, CH2, CH, and in brackets CH3, and then a CH3 again. So because that was in brackets, it's a substituent group. And then when I number it, I'm going to number from the right so that the substituent group is on the lowest numbered carbon. So that will give me 2-methylpentane because it's a 5-carbon chain. Now part C, you were given CH3, CH2, CH, CH3 was in brackets, CH, CH3 was in brackets again, and a CH3. So when you draw that out, you've got a 5-carbon chain with 2 substituents because there was 2 brackets. And then numbering, I'm numbering again from the right to the left so that the substituents are on the lowest numbered carbons. So that will give me then a methyl on 2 and a methyl on 3, so it's 2,3-dimethylpentane. You were given in your book CH3, CH in brackets CH3, CH in brackets CH3, and CH3 again. So when you draw that out, you're putting your what's in brackets as substituents. This time I'm going to it doesn't matter if I number from the left or from the right, because both the first substituent will be on carbon number 2 if I number from the left, and the first substituent would be on carbon number 2 if I numbered from the right. So it wouldn't matter. So in this case it's 2,3-dimethylbutane because it's a 4-carbon chain. Okay, question 2, you were given compounds and you had to draw them out. So the compound you were given was 2-methylbutane. Butane means 4 carbons, 1, 2, 3, 4. On carbon number 2, you put your methyl substituent group. Part B was 2,3-dimethylbutane. So butane means a 4-carbon chain. Doesn't matter whether I number from the left or from the right, because either way there's a methyl group on carbon number 2 and a methyl group on carbon number 3. Part C was cyclohexane. Remember, that's your ring structure. It just gave you the name. You didn't need to write the molecular formula or anything, but remember what we said, for a ring structure like this, it wouldn't have the normal alkane general formula because you've lost 2 extra hydrogens there when making the extra covalent bond. And in part D, you had to draw out this structure here. So this one was 2, 4. So in this one, in part D, we've got 1, 2, 3, 4, 5, 6, 7 carbon chain is a heptane molecule. So it was 2,2-dimethyl, 4-ethyl heptane. And normally, actually, you'd put the substituent groups in alphabetical order. So to be completely correct, that should be 4-ethyl, 2,2-dimethyl heptane. So on carbon number 2, I put 2 methyl groups, dimethyl, and carbon number 4, I put an ethyl group. Okay, now down to question 3. In this one, you were drawing them. So in this one, you had to draw pent1-ene. Okay, pent1-ene is a 5-carbon chain, and on carbon number 1, so it was CH3, CH2, CH2, CH, CH2. So when you're drawing it out, you can see that it's an alkene molecule because there's a double bond on the first carbon. So numbering from the right, I'm going to get carbon number 1, carbon number 2. Make sure that the double bond is on the lowest numbered carbon. Okay, pent1-ene. Part B, we were given CH3, CH, CH, CH2, CH3. So when we're drawing that out, making sure that each carbon just has 4 bonds around it, we'll see that carbon number 2 has the double bond. So that means when I'm numbering it, it's pent-2-ene. Part C, so we have CH3, CH2, CH2, C, and then a C2H5 in brackets, and then a CH2. So when I'm drawing that out, again, look what I'll have here. I'll have a double bond on the first carbon, so I'll number from the right to make sure that the double bond is on the lowest numbered carbon. And then on carbon number 2, I've got an ethyl group, C2H5. And this last one here is CH3, CH, C with CH3 in brackets, and then CH3. Again, I'm going to draw it out. I'm going to make sure there's 4 bonds around every carbon. And when I do that, I can see that the double bond is on carbon number 2, and I'm going to number from the right to make sure the double bond is on the lowest number carbon. So this then becomes